Type 2 ionic compounds with special ions, formulas to names. Okay? Let's say we're given a formula and we want to write the name. Okay? So I'm going to do an upside down T-chart and we're going to work the chart backwards. Now, let's just see if someone can do this. Dee Dee, just say the name of this. Using the same rules that we have applied before, what is the name of this? Dee Dee can do it. So Cu is copper, and N is? But when nitrogen is in a compound, we don't say nitrogen, we say nitride. So if you say this, yeah, that's what you would think if it was a type 1. But this is a type 2, which means there's going to have to be some Roman numerals in it. Right? Our first inclination is just to say copper nitride. But that's not the whole story because we don't know whether it's copper 1, we don't know whether it's copper 2, we don't know whether it's copper 3. Right? So in order to figure that out, we're going to do our T-chart, and that's a little out of whack. Let me straighten it up. So like I was telling someone over here, let's go ahead and draw the line so that you got it separating your cation over here from your anion. Remember the parentheses are going with our cation. All right? We know that nitride is nitrogen, and the symbol for nitrogen is N. Okay, this is where we were about 3 minutes ago. So what is the oxidation number for nitrogen? 3 minus. Okay. Oh, I erased my formula down here. Let's see, Cu3N. All right. And we know that the symbol for copper is Cu, but we don't know what the oxidation number is. Could be a copper 1, could be a copper 2. Hang on a second. I know you're excited. All right. So Oscar, in this chemical formula here,
3 coppers.
hang on. Yes. How many nitrogen?
3 minus.
How many nitrogens in this chemical formula? There's 1 nitrogen, right? So how many coppers are there? 3. Okay, so I'm going to write 3 Cus right here. Okay? So this chemical formulation is illustrated here in the T-chart with the number of particles. I got 1 nitrogen and I got 3 coppers, right? Now we know that the oxidation number for nitrogen is and always will be a 3 minus. I got 1 of them, so I bring down the total 3 minus. Now, hang on a second. In order to make this compound, if I have a 3 minus over here, I have to have a 3 plus on this side. Okay? This 3 plus, now remember these words because you may not understand it now, but you will in just a minute. The sum total of the oxidation numbers on this side will have to be distributed equally among all the particles on this side. So the question is, what plus what equals 3? 1, right? So each of these has to be a 1 plus. Okay? This was the entire object of the game, was to figure out what the oxidation number was so that we know what goes in there. So if there's a copper 1 plus, what Roman numeral goes in the box? 1. So it's working the T-chart backwards to figure out what the oxidation number of the cation is so that we know what Roman numeral to put in parentheses. Okay? Yes. All right, now you practice